Hello everyone. Today I will talk about building energy performance of complex forms. First of all, I would like to start with my previous work. Actually, I'm trying to improve this work. As you all know that there are many optimization studies, but I can say that a few of them includes complex forms to the optimization process. But I think inclusion of complex forms to the optimization process is an important issue because complex forms have a great potential to create energy efficient forms. Because these complex forms could have many geometrical variations that they could be fit to the selected site easily. Also, I made a model which includes minimal surface as a complex form. I also have some other objectives related to the energy efficiency, like maximizing daylighting, minimizing radiation. And I also have one other objective related to the building itself. It is maximizing floor area. I use many grasshopper add-ons for creation of this model. I use ladybug, honeybee, and octopus. Octopus is the main add-on for optimization process. It uses genetic algorithm. And I have some variables in this model. Actually, this variables is the variables of parametric geometry. And some of these variables are related to the general building form, and some of them are related to the openings in this form, like windows. And I made some tests to validate this model, and you can see the three of the results. Yeah, it seems that this model is working, and it tries to increase daylighting in the interior side, and it tries to reduce the radiation at the roof, and at the same time it tries to enlarge the floor area. But the problem is I could get a few generations, and maybe this model needs more tests for validation. And that's why I create a second model that I will talk about a little later. In this model, I used annual daylighting simulation, which takes too long time. In the second model, I actually focused on modification of this daylighting simulation. I also want to talk about one other aspect of this study. I actually compared the complex form with its regular, or I can say the Euclidean version of it. And according to objectives, it seems that this the complex form is more energy efficient than its regular version, as you can see in the results. So let's talk about the second test. In this model, I actually put a limit to the daylighting simulation. I put a maximum limit. And I also use daily basis daylighting simulation, which shortens the simulation time in the optimization process. And you can see that I get 7 generations, so I could get more optimized forms. Like there are many optimized form alternatives I get at the end of the test. You can see the two of them in the screen, and this is the third one. Yes, again, it seems that it tries to increase daylighting in the interior side, and it tries to reduce radiation on the roof. At the same time, it tries to enlarge the ground floor area. And at the same time, it tries to adapt the windows according to the objectives. As you can see, 3 different forms have 3 different types of windows. So I can say that yes, the model is working effectively, and it is very easy to use. And actually, I explained in detail in the paper. Um, it is easy to use and easy to create, and it can be modified according to the objectives. Of course, um, uh, it's it's the objectives are depends on the selected site. Also, I can say that optimization with the complex forms is it's a good subject to study, because I think complex forms can give us they are capable of creating more energy efficient buildings.